Ewelina, maybe we could begin with a layman's definition of Raman spectroscopy and something about how practically it works.
Sure. So actually, we are working with different vibrational spectroscopic techniques. So that's Raman spectroscopy as well as attenuated total reflection Fourier transform infrared spectroscopy, known also as ATR, FTIR spectroscopy. And those techniques actually apply light, more specific photons of light, in order to vibrate the molecules that are within the materials. And they give the very unique characterization of the sample based on the chemical and biochemical composition of the material that it's been analyzed.
Great. So is it essentially looking at the vibrations within a sample and analyzing that, or how else would you describe the process?
So yes, it's actually based on the vibration that the energy of the photon gave to the molecule, and then those vibrations can be visible in the spectrum that is created as a result of the analysis.
So how can this be used in the context of solving and prosecuting crimes?
So since vibrational spectroscopic techniques give very specific and very unique signature of each individual sample, there is no two samples that will give the same signature, the same spectrum. That's why once we have different samples to be analyzed, we actually get different spectra, different signatures of those samples, which are very specific, and they are the signatures of the specific samples.
So it's almost like sounds like a fingerprint, and everyone's is different.
Yes, exactly. That's basically it.
Right. So you describe in your study the array of samples that can be analyzed with Raman spectroscopy. You mentioned substances like nail polish. It can be hair, blood, or drugs. So how is it that this technique works on so many different types of trace evidence?
So since this technique is very specific, due to the unique spectrum which is created based on the chemical or biochemical composition of the sample, the signatures will be very unique. And let me just give you examples, since the advantages of this technique, especially the ATR, FTR spectroscopy, has been already discovered for the forensic applications. And that technique has been already used for several type of analysis types. For example, for controlled substances, as well as fibers and paint analysis. So the idea is that, maybe let me tell you the example. When we have controlled substance and there was a questioned powder on the crime scene, and this substance can be analyzed, and it's going to have different signature than anything else, let's say, if that could have been flour. That's why we can simply distinguish between different substances. Also, for paint analysis, if, let's say, there was a hit and run incident, and we have a sample, the paint chip, that has been collected from the crime scene, its chemical composition can be checked, and it can be compared to the chemical composition of the paint chip that was taken from the suspect car. And then that chemical composition can be then compared, and we can see whether or not the two paint chips could have had the same origin.
And so is this all that is done on the lab, or is any of this, can this be analyzed on site?
So that's actually the ultimate goal. I believe for now there's mostly everything done in the lab, but there are already portable or even handheld instruments, so devices as big as your cell phone, that can be brought to the crime scene. And that is actually great advantage because the actual analysis is really quick. It's the matter of seconds to obtain the spectrum. That's why having the device that can be sensitive enough and the entire analysis that could be performed at the crime scene would be very beneficial and would save time, as well as also could determine what type of evidence should be actually collected from the crime scene for further analysis. So that could definitely save money as well for forensic investigators.
Would you go into what your colleagues are working on in the lab as far as analyzing bodily fluids?
So in Dr. Letnev's research lab, we are actually working to develop the technique for identification and analysis of body fluids for forensic purposes. And the goal is actually to develop the technique that would be non-destructive to the sample, that would be rapid, that would be universal for all of them, and that could actually be performed on scene with statistical confidence. That is very important. And it is actually very important that in our laboratory we actually stay in close collaboration with New York State Police in order to get advice and discuss all problems. And in our research, we actually try to address all needs the police or forensic investigators could have at this moment. That's why we are actually working. We are trying to address everything they might have need and they might have find beneficial for future forensic research, forensic applications at the crime scene.
Oh, that's pretty amazing that so much information can be garnered just from a tiny speck of a sample that's found on a crime scene. Well, this is such a specialized field. I'm interested to know how you first got interested in it and what led you to the particular research project you're on right now.
So I was always interested in forensic work and forensic research, and I always wanted to work in forensic lab since it seems to be more interesting than any lab work. And when I had a chance to pick a place for my internship during the undergraduate program, I decided to do it in forensics, and my desire was to actually come all the way to United States to do it in order to get the best possible education. So I came all the way from Poland to perform my research in United States, and I found Dr. Lednev's research lab as a perfect place for me, especially that there's so much that I can learn about current forensic practices as well as actually work on new development of different applications of different methods for forensic analysis. So I found all the research really fascinating, and when I was undergraduate student, I was already working on projects similar to those that PhD students were working on, and I published papers as an undergraduate student as a first author. So that was very challenging, but it gave me huge experience and I learned a lot from that. So later on, it was really easy decision for me to make and choose the university. So I came back to Dr. Lednev Research Lab for my PhD program, and now I continue working on similar projects. I continue developing new techniques for forensic applications. And it's really fascinating how actually this work is important for real applications. So in our laboratory, we've got few NIJ, National Institute of Justice Graduate Research Fellowship. So far, it's been 3 students receiving those fellowships for last couple of years. And I would just want to mention that there's only about 20 fellowships that are given every year to entire United States.
And you guys have 3 of them.
So it's been already 3 given for last few years, and including myself. So it shows how important the research and the work that is being done in our lab actually is for forensic community.
Well, and it's neat to hear about you collaborating with the New York State Police as well. That must be assuring that you're working on the problems that matter and really fitting their needs of what they need to know when they get to a crime scene.
Yes, that's right, and it's really fascinating and it's exciting that we actually can feel what they need and we can address that and work on it more and develop something new that could actually potentially be used in near future.
Very cool. Well, can you share any moments or epiphanies that perhaps surprised you when conducting this research? And can you share any of your project's most important or significant findings?
So, as I mentioned, I've been kind of faced to a lot of challenges, especially when I started in Professor Lednev's research lab as undergraduate student. But then, because of all kindness and help from other co-workers' side, I was able to perform everything, and the publications that I've done, that I finished studies for, were a great testimony about how actually important the research is, and that we are doing a great job in development of something new, something important. So I think that those moments were really significant for my research. And as well as all awards and all presentations I can give on national or even international conferences and symposia. So that shows the interest of people and the interest of audience on really wide range that I was able to actually present to.
So this research is part of your PhD program. So when do you hope to finish, and what's next after graduation for Ewelina Mistek?
So I'm hoping to finish within next 2 years. We'll see how it goes, and I still didn't think too much about further career for myself. I was thinking of going back to Poland and maybe working over there, developing some new forensic applications for my home country. But maybe I will stay here if there's some possibilities, some new challenges for myself. So still didn't make a plan.
Ewelina, thank you so much for sharing your research.
Thank you very much.